Okay, so in this video, we'll see how we can add a new task to our project and customize the attributes of the MDP function, the reward function, or even the reinforcement learning parameters in our task, right? So luckily, the IsaacLab template project has hundreds of standard template tasks that already come with it. And it's pretty simple for you to just copy them from there into your external project so that you can customize them and play around with them, right? So the process is pretty simple. As I said before, the hardest part here is probably to know the folder structure and to know where things are saved. So I have here on my left side my IsaacLab template project that we downloaded from GitHub. And on my right side, I have my external project that I called my IsaacLab Project 7, right? So what you want to do is you have to go into the IsaacLab master project and then find the template tasks. So they're here inside the source folder. If you go IsaacLab tasks, you have both manager-based or direct types of tasks. I'm just going to go for the manager-based, classic, and I want to copy this humanoid task into my project, right? So as we saw before, our task got created only with a carpal task, and now I want to add the humanoid task to it. So where should I copy this into my project, right? So this is something else that you need to pay attention, and it's kind of hard to suss out. But you also want to come into sources, my IsaacLab project, tasks, manager based, right? So here's my carpal task. I previously renamed this folder, and I simply gonna go Control C, Control V, and I paste it here. Now I have to adjust a few files here for this to work, right? So the first thing is I want to go into this init Python file inside my manager base folder, and I'm going to import the humanoid library into this project here, right? So I'm just going to copy this from .import humanoid, save and close. And something else that I need to customize is inside the humanoid folder, there is another init file. I'm gonna open it and I want to rename my project, right? So this is the name of the standard task that comes with IsaacLab. But the problem is that this name is already registered on Gymnasium. And if you just try running your task from inside your project, it will have a name conflict and it will error out because it'll say that, well, there's already a task with this name registered on Gymnasium and you cannot run a different one under the same name, right? So as a good practice, I'm just going to add template dash whatever the name is. So by adding template dash as a prefix, not only it avoids the name conflict, but it also makes it findable by our list environments command, right? So right after we'll list all our template, all of our custom environments, and this prefix makes all of our template um, customized tasks findable by these command, right? So it's pretty useful if you want to just show your custom tasks in the CLI, right? So I did this, and here I'm back on my Anaconda prompt CLI. I have already activated my environment, my Python environment. I'm inside the project folder, and now I want to list all the uh, all the environments that I have, right? So I'm just gonna go and run script lists environments.py. Okay, I forgot to add Python. There you go. So hopefully it will list our um, all the um, all the tasks that are registered, right? So I have already run this task before, so it has already registered on Gymnasium. So this is why we have it here, template Isaac humanoid v0, right? So again, this command here, it lists all your custom environments that have this prefix before, right? And the way you use it is, okay, so instead of just showing all the hundreds IsaacLab tasks that already come with the project, just list the ones that I created, right? So if you want to do this, you have to add template dash, and using this command, it will list only your tasks, right? Okay, so now I'm gonna just run this just to make sure that I did everything right, and just to have a baseline of what the running parameters are. So again, it's the same command. You want to run the train.py script and just pass the name of your task that you just renamed in it, right? So it's going to run the humanoid task. It's opening Isaac Sim to show the simulation. So there you have it, all the humanoids. And notice that on the parameters here, it's using learning iteration out of 1000, right? So just note this because this is going to be one parameter that we are going to change. So just keep this number in mind so that you know that there was a baseline, and we're going to change it now, right? So how do we modify the parameters, right? So I'm in my external project folder here, and the first one that we are going to change are the reward function parameters, or the MDP parameters, right? Markov decision process function. So I want to open this file here under the humanoid project that I just copied, humanoid environment config. And if you scroll down, you'll see this function here, or this class creation rewards config. And this is where you have the reward terms for your MDP function, for your reward function, right? So each one of these is basically defining how to reward the robot for each one of these milestones, so to speak, right? So here I'm not going to change the structure. I'm just going to change the number, the amount of the reward, right? Or the weight of the reward, right? So first one here, we have the reward for moving forward, right? So um, this is weight 1. I'm just gonna emphasize it more, and I'll give it weight 2, so the robot will be more prone to moving forward when it learns, right? The stay alive bonus here is weight number 2. I'm just gonna decrease it to 1. So this will make the robot a little more of a risk taker. It will try to take more risks instead of just trying to stay alive. So maybe it will make it learn faster. Who knows? Reward for known upright posture. I'm just going to leave it as it is. Reward for moving in the right direction. Just going to leave it as it is as well. Penalty for large action commands. So also this is something that intends to stabilize the movements and make the robot avoid that the robot starts like wiggling around too much. I'm going to decrease it a little bit just to make the robot a little more creative in its moves. And penalty for energy consumption also. This is um, another balancing parameter that you can use to make the robot more energy efficient while it's learning. Penalty for reaching close to giant limits. Again, I'm going to lower it down, trying to make the robot a little more creative in its movements and not so uptight, right? So I don't know whether this will yield better results or not, but I'm just changing it for the sake of this experimentation, right? So I just changed the weights here. I'm going to save and close. And also what you can do is to change the parameters of your reinforcement learning algorithm, right? So here on humanoid environment underline config, we changed how the robot is rewarded by its learnings. And then here, if I go inside agents, I have all the uh, algorithms that you can use, and I can configure how you can tune the reinforcement learning algorithm. So I'm going to use the RSL reinforcement learning PPO. You can use RL Games, SP3. These are all types of algorithms that you can use to run this reinforcement learning task. I'm gonna open this one, and here is where I can customize my reinforcement learning algorithm parameters, right? So this teaches or this tells the pipeline how to run the training runs. Not exactly how the robot should behave, but how to run the training sessions or how the robot should learn. So the first one that I'm going to change, what I mentioned on the beginning, is the number of maximum iterations. So I'm going to lower it down to 50 just to make it finish faster. The other parameters that I'm going to switch is you have the clip parameter, right? So this is how different or similar the update on a policy is from the last version, right? So if this is higher, it means that the updates are smoother and closer to the previous version. If it's lower, it means that you can have updates that are uh, more different from the previous version, right? So it makes it the learning a little more. If you lower down, it makes the learning a little more, um, uh, let's say, advanced or not advanced, but it makes it change in larger bumps, right? Which can be risky, but it also can leading to faster learning depending on the case. Number of learning epochs, I am going to go with 8 here. So this is how many epochs it will run for each learning update. Uh, Entropy coefficient, this is also one of the parameters that defines how creative or how risk taker the learning process can be, right? So if you raise it here, it will make the robot explore more. try different moves instead of um, just being conservative or focusing on what is already working, right? The learning rate, again, is the size of the step by which the algorithm is learning. So if you go too high, it can maybe learn faster, but it can also just just rush through the point of the optimal point, and then it can also be risky, right? So I am going to um, make it a little larger here and see if it converges faster or if it actually depletes my rewards, right? So I'm just gonna leave the rest as is. Just gonna save and close here, right? So I modified the MDP function parameters, the training parameters, and now I'm going to go and run that again, right? So again, here back to my CLI, I'm just going to, again, pass the command to run train.py with the name of my task, template, um, humanoid. So if I run it, it's opening IsaacSim again. There you have it. The simulation is running. And if we go back to our CLI, then you can see that the learning iteration parameter has already updated with the customized value, which is a maximum of 50 here. And all the rest is running on the parameters that we just customized, right? So I'm not sure if it will yield better or worse results. I was just trying to tweak a little bit with the parameters. So um, hopefully with the parameters that I use, the robots are a little more crazier because I switched the parameters for them to be more exploratory, risk takers, having less boundaries, and apparently their initial moves are doing just that. So there are some that are like wiggling around all over the place. So I'm not sure if these values are a good practice if you're training a task for real, but this was just to show how you can copy a new project to your external copy a new task to your external project and customize the parameters.